For today's class, we are going to talk about fractions. Recall, in our first video, I explained that numbers are either real or complex. Real numbers are either rational or irrational. Then for rational numbers, they are either whole numbers, which we call integers, or fractions. So in our previous lessons, we focused on integers. Now we want to talk about fractions. Let me ask you this. What is this? You can tell me it's a square or rectangle. So let's suppose it's a square. So how many squares do we have here? We have one square. So this 100% square, it is complete square, 100%. So meaning 1 and 100% are the same. 1 equals to 100% or 100% is 1. But by the time I divide this into two equal parts, how many parts do we have? We have one. We have two parts, right? So it was one square before, but that one square is now divided into what? Two parts. So each part is what? Half half. So you can also say that one equals to half plus half. So this is fraction. Fraction means a part of a whole. So it was 100% before. This side is now 50%. This side is also 50%. So you can say the box was 100% before, but now it is what? Into 50%. Okay, let's take this side and let's now divide it into two. So what happened? This was half, everything was half, but now this half have been divided into two. This also is divided into two. What happens when you divide half into two? Half divided by what? 2. We can write this 2 as 2 over 1, same thing. In mathematics, whenever you turn division to multiplication, this number after this sign, we turn upside down. So this one will go up, this will come down. 1 times 1, 1, 2 times 2, 4. It means this side now is now 4, which we call a quarter. A quarter, a quarter. So meaning half is actually what? Half is addition of what? 2 quarters. 4 plus 1 over 4 will give us half. So, but yeah, this whole box has 3 parts now. Part 1, 2, 3. So if I add half and I add 1 over 4 plus 1 over 4, I must get 1. Right? Yes. Okay, let me take this part now and let's divide this one into 2 again. Let's divide it into 2. Everything was 1 over 4. So 1 over 4 here has been divided into 2. Same thing here, into what? 2. So if we divide 1 over 4 into 2, 2 by 1, that's 1 over 4 times 1 over 2. 2 times 4, 8. That is 1 over 8. It means this side is what? 1 over 8. This side is what? 1 over 8. So here it implies that first 1 is half plus half. Half is 1 over 4 plus 1 over 4. Then 1 over 4 equals to 1 over 8 plus 1 over 8. Okay? What if I divide this one into 2 again? If you follow the pattern from 2 to 4 to 8, that is powers of 2. So this one actually got 1 over 16. 1 over 16. Okay? Let me divide it again. Let's now take this one and divide it into 2. So if we divide this into 2, it becomes what? 1 over 32. 1 over 32. If we add all the fractions here, we must get 1. So let's write a giant 1. So now, if we add the half part of the box plus the quarter part plus the half of the quarter plus 1 over 16 plus 1 over 32 plus 1 over 32, we must get what? 1, because we have only one box. So this is in fraction, which you can also write in percentage. But first, let's show that this is 1. How can we show that? Note, to add fractions, they must have the same denominator. They must have 1 over 2 plus 1 over 4, we can't add them. For example, we know that if I had 1 over 32 plus 1 over 32, we are going to get 1 over 16. 1 over 16 plus 1 over 16 will give us 1 over 8. 1 over 8 plus 1 over 8 will give us 1 over 4. 1 over 4 plus 1 over 4 will give us what? Half. Half plus half will give us 1. So if you're adding, they must be like. We only add like fractions if they have the same denominator. So what can we do here? So here you look for the biggest number, 32. You want to show that everything here is 1. You want to show that 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32 plus 1 over 32. You want to show everything should be 1. So what can we do? So we have to go back to our last class. The concept of what? LCM. So what is the LCM of 2, 4, 8, 16, 32, 32? The answer is 32. Why? Because 2 can divide 4, 4 can divide 8, 8 divides 16, 16 divides 32. So the LCM is 32. But before that, we want to make everything here to 32. So we want them to have the same denominator. So what are we going to do? What can we multiply by 2 to give us 32? Or let's use 32 over 2, that's what? 16. So we multiply numerator and denominator by 16 so that we have 32 at the end of the day. So I'm multiplying by 16 by 16. So 32 over 4 will give us what? So I divide this one by multiply by 8 by 8. 8 in 34, 32 should be 4. Multiply by 4, multiply by 4. 16 32 is 2. Multiply by 2, multiply by 2. Since we multiply the numerator and the denominator with the same number, we are not changing anything. Now let's multiply. 6 times 1, so this is what? 16 over 32. Plus this one is what? 8 over 32. This one is what? 4 over 32. This one is what? 2 over 32. Then 1 over 32 plus 1 over 32. What happened? They have the same denominator. So if they have the same denominator, you pick only one of them. Then we add all the numerators. So what do you have there? 16 plus 8 plus 4 plus 2 plus 1 plus 1. 16 plus 8. Okay, let's start from the back. 1 plus 1, 2. Plus 2 plus 2, 16. 16 plus, is that 16 or 8? 8. 8 plus 8, 16. 16 plus 16, 32. So the whole numerator is what? 32 out of 32. So obviously, what's the answer here? 1. That is it. Now let's turn this to percentage. This same box, we want to use percentage. You know, I said it at the beginning of the class, sorry, this series. The fraction can either be vulgar, percentage, or in decimal form. So all we have here is vulgar fraction, and they are all proper fractions. So for improper fraction, it is the addition of proper fraction and whole number. So for now, we want to focus on proper fraction. So but now let's go to percentage. How do we convert fraction to percentages? So this is 100%. I'm 100% certain that this is the box. So but by the time we do this, it means we divide 100 into 2 parts. So this becomes 50%. This is also 50%. If I divide this 50% into 2, that will give us 25%. 25%. If we divide 25% into 2, we're getting half of 25 is 12.5%. And this is also what? 12.5%. So let's divide 12.5% into 2. We might need to do a small mathematics there. 12.5 divided by 2. 2 in 12 is 6. 2 in 5 is, you can write that as 50. So if you divide this 50 by 2, that will be 25. So this is 6.25. This is 6.25. Let's now divide into 2 again. So divide 6.25 by 2. 2 in 6 is 3. 2 in 2 is 1. I can put 0 here again. 2 in 5 is what? 2, 5. That's 3.15. So this is 3.15. This is also 3.15. So what does this mean? It means 1 over 32 is what? 3.15. 6.25% is 1 over 6. 2.5% is what? 1 over 8. 25% is what? 1 over 4. And half is what? 50%. So if you add everything here, we should get 100%. Let's do that. We want to add 50% to 25% to 12.5% to 6.25% to 3. No, it's not 3.15. It is 125. So 3.125, 125. That box is small. Plus 3.125%. Let's add. We've done addition already, so let's do that. So I'll write the biggest number first, 50. Then 25. Then 12.5. This one has no decimal point, so you can put 0.0 each. Then it's 6.25. 6.25. All decimal point must align. 3.15, 3.125, then another 3.125. Let's add everything and see what we're going to get. So 5 plus 5, 10, 0 carry 1. The one over here. 1 plus 5, 6, plus 2, 8, plus 2, 10, 0 carry another 1. 1 plus 5, 6, plus 2, 8, plus 1, 9, plus 1, 10, 0 carry 1. Put the 1 here. 1 plus 5, 6, plus 2, 8, plus 2, 14, plus 3, 17, plus 3, 20. 0 carry 2. 2 plus 5, 7, plus 2, 9, plus that's 10. So this is what? 100%. Now how do we convert from directly to decimal? Sorry, fraction directly to what? I'll just take two of these. According to what we have here, so this is 50%, 50%, 25%, 25%. This is 12.5, 4 over 32. 6.25, 2 over 32. 3.125, 1 over 32. 3.125, 1 over 32. So suppose we are given 1 over 32. How do you convert to percentage? And if you are given percentage, how do you convert to what? Fraction. So what you are going to do now is, how do we convert from fraction to percentage, or percentage to fraction? Then after doing that, we now do addition of fractions. How do we add fractions? Although according to what we have here, we can only add fraction if they have the same denominator, but there are many other methods to use. So first, let's go into how to convert from between vulgar fractions and percentage. All right, conversion of vulgar fractions to percentage. Let's take these examples. Now we have to express the following fractions in percentage. Question 1. So half to percentage. Note, 100% is same thing as 1. So if I multiply half by 1, it's the same thing as what half. Any number multiplied by 1 gives that number. So I can replace 1 with 100%. Then 2 can divide 100. If you divide 100 by 2, you get 50. So which times 1 is 50. So it means half is what? 50%. Second one, 1 over 4. To convert it, just multiply by 100%. So 4 here 1, 4 in 100 is 25. So 25 times 1 is 25. So what's the answer? 25%. Next, if I have 3 over 4 in fraction to percentage, multiply by 100%. So let's do that. 4 here 1, 4 in 100 is 25. Then we do 3 multiplies 25, and that is 75%. Number 4, we have 12 over 25. To convert percentage, we multiply by 100%. 25 here 1, 25 here will give us 4. 4 times 12 will give us 48%. Question 5, we have 3 out of 20 times 100%. So from here, 20 here 1, 20 100 should give us 5. 5 times 3, 15. That is what? 15%. Pretty straightforward. It is pretty straightforward. Now let's do the opposite. Percentage to vulgar fraction. Express the following percentages to fractions. So anytime the word fraction is used, most times it's referring to vulgar fraction. But if it's decimal fraction, you just say decimal. So now what do we do? It's very simple. The first one, number 6, 18%. And I told you, percent means out of 100. So 18% actually means 18 out of 100. For number 7, 32% means 32 out of 100. Number 8, 85% means 85 out of 100. Number 9, 6.25% means 6.25 out of 100. And number 10, 175% means 175 out of 100. I told you, percentage is meant to be maximum of percentage. The maximum is 100%. Anything more than 100% means it is what? Improper. So and we are going to get what we call improper fraction. So number 10, we'll link number 10 to improper fraction. So, but the thing is, in mathematics, we don't just express number this way. We have to put them to the least, using the least digit to represent them. So you check what can divide 18 and 100. So 2 can divide. So come here because 18 is even. 2 in 18 is 9. 2 in 100 is 50. So the answer is 9 out of 50. For here, 2 in 32 is 16. 2 in 100 is 50. But we can still go on. 2 in 16 is 8. 2 in 50 is 25. And I think that was it. Full stop. For here, 2 cannot go. Even 3 cannot go because if you add 8 plus 5, it is not a multiple of 3. So 5 can go. So 5 in 8 is 5. So 5 in 8 is 1 remainder 3. 5 in 35, 5 times 7, 25. Then 5 in 10, that's 2, 0, 17 over 20. Now for this one, we've not done decimal, but if you have something like this, what can we do? So what you can do is, look at this. Anytime we have a decimal, we can there's a way we can remove what? The decimal point. I can write 6.25 as what? 625. We just neglect decimal point. But anytime we neglect decimal point, we count. We have two numbers after this 6.25. So it means if I have 6.25, it is actually what? 625 divided by 100. Suppose it is 62.5. That's what? 625 over 10. If it's 0.625, that is 625 over 1000. Meaning, if you neglect decimal point, if you have two numbers at the end, after the 2 zeros, if it's one number 1, number 3 zeros. Already, we have 2 zeros before, 2 zeros. Now, since we neglect this decimal point, we are going to add 2 zeros here again. So, 6.25% in fraction, but we still have to cut it to the last bit. So, this will, don't panic. 2 can go, 5 can go. Yeah. Now, how do we divide? So let's use 5 because 5 can divide both. So 5 in 6 is 1. Remainder 1. 5 in 12 is 2. Remainder 2. 5 in 25 is 5. So that's 1, 2, 5. Then 5 in 10 is what? 2. Then we have what? 3 zeros. 5 can still go. 5 in 12, 2. 5 in 12 is 2. Remainder 2. 5 in 25 is 5. Then 5 in 20 is 4. That's 400. 5 can still go. 5 in 25 is 5. 5 in 40. 5 times 8, 40. So that's 5 over 80. But that's not the end because 5 can still go. 5 in 5, 1. 5 in 8, 1. Without 3. So 5 in 30, and that should be 5 times 6, 30. So that's 1 over 16. So if you go back to the beginning of this video, when we drew the box, so 1 is actually what? 6.25. So that is how to convert these to, fraction. And for the last one, let's cut. 5 can go here also. 5 cannot go in 1. 5 in 17, that's 3. Remainder 2. 5 in 25, that is 5. Then 5 in 10, that is 2. 0. 5 can still go. So 5 in 75 in 35 is what? 7. 7 times 5, 35. 5 in 20, that is 4. So as you can see, 7 over 4 is what? Improper fraction. Because this percentage is more than 100. So whenever we have improper, you should learn how to convert to what? Proper fraction. So the next thing I want to look into is how can we convert improper to mixed fraction. Already from what we did here, we've already learned how to convert decimal to fraction. This is decimal to fraction. So because the next one we are meant to look into is what? Decimals. How can we convert percentage to decimal? How can we convert decimal to percentage and likes? So the next will be on decimal. But before that, let's talk about improper fraction. How do we convert improper to mixed and mixed back to improper? You can write this place before we continue. Improper fractions. So these are improper fractions. As you can see here, one digit. 2 numerator, 1 denominator. 2, 1. This is 3, 1. This is 3, 2, 3, 3. Oh, I didn't add when we have 2 up and 2 down, 2 digits. So let me add that one. If you have to have 2 digits up and 2 digits down, so let me use 97 over 13. So I'm trying to get the possible things you can be told. Let's even do 4 digits. So 4 digits and 2 digits. For example, let's say we have 2009 divided by 29. How do we go about this? I'm trying to give you, to give possible examples or possible questions that you can be given. So from the simplest to the toughest. One thing that will help you here is the multiplication table. The multiplication table I told you to memorize, So how many 2 can we see in 3? It's as though 3 over 2 is, we have 1, 2, 3. So how many 2s do we have here? 2 appear only once. So 2 appears only once. Then we are left with 1 out of the 2. So that is it, 3 over 2. And we can show it diagrammatically. Suppose I have a box divided into 3 sections. So this is what? Oh, sorry. We have a single box and half of a single box. So this is 3 over 2. Why? Because we can divide everything into 4 parts. So we have 1, 2, 3, 4. What is shaded? So we have half here, half here, half here. That's 3 halves. So 3 halves gives us 3 over 2. Improper fraction. Okay, 8 over 3. 1, 2, 3, 4, 5, 6, 7, 8. How many 3 do we have there? 3, 3. So 3 appear 2 times. We are left with 2 over 3. What about 19? Okay, let's continue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So in 4 places. 4, 4, 4, 4. Remaining 3. 4 appears how many times? 1, 2, 3, 4. We have 4 fours and we have 3 lefts out of the what? 4 distribution. So over 85, are you going to write 85 strokes? That's where it gets interesting. So you don't have to use stroke always, but you need to master the multiplication table. So for this, you ask yourself, go to the multiplication table, the multiples of 9. Which of them is closer to 85? For example, if you do 9 times 9, you get 81. 9 times 9 is 81. 9 times 10 is 90. So 85 falls in between. So meaning the maximum is to use 9. So how many 9 can we see in 85? 9. Because that will give us 81. If you now remove 81 from 85, you'll be left with 4. So it means 1, 2, 3, 4, 5, 6, 7, 8, 9. We have this 9 times. We have it 9 times. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Then the last one will be grouped into us. How many? They are going to have how many strokes left? 4 strokes. 1, 2, 3, 4. So if you draw strokes, if you draw 85 strokes and you group them 9, 9, 9, 9. So you can see 9 nines, then you'll be left with what? 4. Out of what? The 9 division. 9 number 4 over 9. In case you are confused, again, keep multiplying 9 by 1. 9 times 1 times 2 times 3 until you get a number very close to 85, if not exactly 85. So when we go to 9 times 9, you get 81. It's close. But to be certain that's the maximum, we multiply by 9 again, or add 9 to it again. So 9 times 10 is 90, which is more. It should not be more, it should be equal or less. So we are going to use 81. So since 9 times 9 will give us 81, it means 85, 85 can be written as 81 plus 4. So this 81 is actually 9 times 9. So you have 9 in 9 places here, then 4 standing alone. So this 9, write it here, then remainder of it, so we are going to write up. Now for this one, how many 7 can we see 1, 2, so we can do times table. Or if it's a digit, it is easier to take the first 2 digits here. But first we are going to use 2 methods here. If we go to 7 times table, 7 times 10 is what? 70. It's not even close. So can randomly pick a number more than 10. Let's pick 12. What will 12 times 7? So 7 here, 14, with that 1, that's 84. Not even close. Let's pick a bigger number. Let's pick 15. 7 and 15. 7 times 5, that's 5, carry 3. 7 times 1, 7, plus 1, that's 10. 105 is getting closer. Let's use a bigger number. Let's use 17. 17 times 7. 7 times 7, 49, carry 4. 7 times 1, 7 plus this, that's 11. Oh, that's close. Now let's use a number that is more than 70. Let's use 18. 80 times 7. So what is 7 times 8? 56. 6 carry 5. 7 times 1, 7 plus 5, that will be 12. And that is more than 125. So we cannot use 18, it must be 17. So how many 7 can we see 125? 17. What will be the remainder? We remove 119 from 125. So we do 125, 119. So 5 minus 9 possible. Borrow 1 from here, gives 1, this is now 15. 15 minus 9 gives 6. Then 1 minus 1, 0, 0. So the answer is just 6. So that's 6 over 7. That is the final answer. Well, how can we avoid all this random multiplication? So you can do this. You can pick the first 2 digits. So how many 7 can we have in 12? That's 7 times 1, 7. Because 7 times 2 is 14, which is more than 12. That is 1. So remove 7 from 12. 12 minus 7 gives 5. So put the 5 behind this one here. That is 55. Then now add 7 in 55. So 7 times 10, 70 is more. So 7 times 6. Or 7 times 7 is 49. Then 7 times 8 is 54. Very close to 55. So that is what? 7 times 7. Sorry, 7 times 8 is 56, which is more than 55. So we have to use 7. 7 times 7 is 49. So remove 49 from 55, that will be 6. That is a lot faster. So pick 2 digits. If 7 cannot be the first digit, we use the 2. Then the remainder will carry to the back of the next. Let's use this approach for this next one here. For this one, we have 515, 12. So let's do this first 2. How many 12 can we see in 51? 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. 12 times 5, 60, which is more. So it's going to be 48. How many 12 can we see in 51? That is 4, 48. Yeah. Then remove 48 from 51. That should be 3. 48, 49, 50. That's 3. So put the 3 at the back of this 5. That's 35. The next, how many 12 can we see in 35? That will be 2, because 12 times 3 is 36, which is small. 12 times 2 is what? 24. So that is 2. So since you can have 12 in 35 2 times, that's 24. So from 35, we remove 24, we are going to get 11. So that will be 11, 12. So what's the answer? 42 whole number, 11 over 12. Let's use another method. What we just did now, but in a fancy way. We put 12, 515 inside, we put 12 here. So 12 cannot go in 5. So we try 51. 12 in 51, that is 4. Because 4 times 12 is 48. Then what next? We subtract. You can put 0 here before that. So subtract. So let's subtract. 5 minus 0, 5. So 1 minus 8 possible, 1. 11 minus 8 gives us 3. This becomes 4. 4 minus 4, 0, cancel. Then we'll go on again. How many 12 can we see in 35? That should be 2, because 3 is more than 35. And that's 24. We subtract again, and that will be 11. 12 cannot go 11 again, we pause. So what's the answer? The answer is 42 whole number, then remainder over divisor. So 42 number, 11 over 12. Now, 845, they are both 3. Okay, before that, let's do this one. 97 and 13. So if they have equal digits, you can easily guess, because if you have equal digits, their division cannot be, this one cannot be up to 10 times of this one. But if the digits are very far from each other, maybe 3 and 2 or 3 and 1, to guess might be difficult. But for me, you can easily guess what you can multiply to give us 97. Same goes here. If we by 10, that will be 1,290. So let's multiply by something less than 10. Suppose we multiply by 8. What is 129 times 8? If you do that, if you multiply 129 by 8, we get a number over 1,000. So let's use 129 by 6 or by 5 first. multiply 129 by 5, you are going to get 40 something. So let's use by 6. If multiply 129 by 6, we are going to get 774. Let's try by 7. By 7, we get 903, which is small. So the answer is 6 times. So it means 845, 129. So 129 here should be 6 times. So if you multiply 129 by 6, we are going to get 774. Then from here we can subtract. So let's see what we left. 5 minus 4, 1. 4 minus 7 impossible. Borrow 1 from this 8, it becomes 7. So 14. 14 minus 7 gives 7. So what's the answer? 6 number, the quotient. The remainder 71 over divisor 129. Alright, for this one, we can easily guess. If we do 13 times 6 power, let's see what we're going to get. We are going to get 78, which is not up to 79. Let's try by 7. If we multiply by 7, we get 91, which is very close. If you try by 8, it will be far more than 91. So meaning 13 appears in 97 7 times. 30 times 7. So 30 times 7 is 91. 97 minus 91 should give us 6 over 13. What about for this one? So since the digits are very far from each other, we can group. So we can group. How many 29 can we see in 20? It's not possible because 29 is more. So how many 29 can we see in 200? So in 200, how many 29 can we see? Let's use this method. 2009. And we have 29. 29 cannot go in 2, cannot go in 20. In 200, how many 29 can we have? If you multiply 29 by 10, that's 210. It's too much. So 290 is too much. Let's use by 8. You are going to have 72. 16, that's plus 7. Or 17 plus 6, that should be 23. Which is still more than 200. So let's use 6. 29 multiplied by 6. So we are going to get 174 at the end, which is close to 200. And multiplied by 7, we will get a number more than 200. So the best is 6. So 29 can go in 200 6 times. 6 times 29 will give us what? 174. We add 0 here, then we subtract. Let's subtract and see what we are going to get. So 9 minus 0, 9. 0 minus 4 is not impossible. Borrow 2 from this. Borrow 1 from here, it becomes 1. Then put 1 here. We borrow 1 from 10, it becomes 9. Put the 1 here. So 10 minus 4, 6. 9 minus 7, 2, 6, 9. Then we'll divide again. 29 and 26 is impossible. 29 and 2, 6, 9. We can also guess again. Let's use 9. 29 times 9. That's 81. 18. 2 times this 18. 18 plus 8 will give us, that should be 26. 261. Yes, 261 is not up to 269. So 29 and 269 is 9. 9 times 29 is 261. By the time we multiply, we get 8 here. 29 is more than 8, so we stop. So what's the answer here? The answer is the quotient is 69. 69 whole number. Then the remainder, 8 over the divisor, 29. Now I believe you can convert improper to mixed. Now, can we return this one back to this? Yes, it's possible. How? From mixed to improper, we'll do the reverse. 2 times 1, 2. Plus 1, 3 over 2. 3 times 2, 6. 6 plus 2, 8. That will be 8 over 3. 4 times 4, 16. Plus 3, 19. That's 19 over 4. 9 times 9, 81. Plus 4, that is 85. That's what? 85 over 9. 7 times 17 plus 6 will give us 125. 12 times 42 plus 11 will give us 515. 129 times 6 plus 71 will give us 845. 13 times 7 plus 6 will give us 97. 29 times 69 plus 8 will give us what? 209. So you can do this yourself to confirm it. So with this, I believe you can convert improper to mix and mix back to improper. What next? Let's talk about decimals. So we can now look into decimals to fraction to percentage decimals. So we also have proper decimals and improper decimals. Look at this. All these fractions are what? Improper. So if we take out the whole number, we'll be left with what? Proper. So this is proper fraction, proper, 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 proper. So what I'm going to do now is we want to convert all these proper fractions to decimals. So what is 1 over 2 in decimal? So we write numerator inside, denominator outside. 2 in 1 impossible. So write 0. 2 go. The number of 2 we can find in 1 is 0. Then write 0 here. Then put point. When you put point here, put 0 here. Then 2 in 10, 5. Write 5 here. 5 times 2, 10. You subtract 0. So we have no remainder. So from here, it implies that 1 over 2 equals to 0.5. So this is a decimal fraction. Let's go to the next one, 2 over 3. So for 2 over 3, what will be its answer for 2 over 3? Similarly, the numerator will be inside 2, 3 over here. 3 into impossible, 0 point. They write 0 here. 3 in 20, that works. 3 times 6, 18. That will be 6. Multiply 18. Subtract, we get 2. Now the 2 we got is same as the 2 we added initially. So meaning if you continue, we'll be having the same number up here. We'll be having 6, 6, 6. Let's try to do a couple. So let's put 0 here again. 3 in 20, 6. Times 3, 18. Subtract, it gets 2 again. So meaning if you keep going like that, you'll be having 2, 2, 2, 2, 2. And this will keep giving us 6, 6, 6 like that. So it means 2 over 3 is what? 0.6666. It has no end. Although we can approximate. If you approximate, perhaps to 2 decimal places. So the answer will be 0.67. So meaning if you pause at the 7 decimal place here, this is over the first decimal place, 7 decimal place. You also have 7 decimal place. The next number, if the next number is up to 5, 5 and above, we turn it to 1 and add it to the 6. So approximately 2 over 3 is what? 0.67. Now 3 over 4. There's the 3 over 4. What will be 3 over 4? Similar thing. 3 will be inside, 4 will be outside. 4 in 3, 0. 0.0. 4 in 30. So if you should be 4 and 7, that will be 7. 5 times 4, 28. Try to get 2. That you have 0. 4 in 20 is 5. Then 5 times 4 is 20. No more remainder. So what's the answer straight? 0.75. So it means 3 over 4 is 0.75. Next, let's do 4 over 9. 4 over 9. 4 over 9. What will be in decimal? 4 over 9. 4 will be inside, 9 will be outside. 9 in 4, impossible, 0.20 here. So 9 in 40. So I think 9 times 4 is 36. So 4. 4 times 9, 36. Subtract to get 4. Put another 0 here. You are getting 4, 4. It will continue like that. 9 in 40 is 4 again. 4 times 9, 36. Subtract, keep getting 4, 4, 4, 4 like that. So it means 4 over 9 is what? 0.4444. So let's suppose we want to put our answer in 2 decimal places. The next number is not to 5, so we just neglect everything. So approximately 4 over 9 is what? 0.44. Let's do the last one, 11 over 12. Same way, we put 11 inside, 12 outside. 12 and 11, 0. Point, put 0 here. How many 12 can we see in 110? 12 times 10 is 120, which is more than 110. But 12 9 will be than 110. So let's do 9 times 12. What will 9 times 12? 9 times 12 should give us 9 times 12 is 18. 18 than 1. 9 times 1, 9 plus 1, that's 10. That's 108. So 9 times 12 is 108. We subtract again. After subtraction, we get 2. Then you put 0 there. 12 in 0 can only happen once. 1 in 12, 12. Let's subtract again, you get 8. Then put 0. How many 12 can we see in 80? So let's 12 times 5 is 60. 12 times 6 will be 72. That will be 6. But that will be 72. We subtract, we are going to get what again? 8. 8, 8. So meaning if you continue, you getting what? 6, 6, 6, 6, 6, 6 like that. So approximately 11 over 12. Once you get to the third number, you can just stop. If you want your answer to be in 2 decimal places. After the first and second decimal places, the next number is more than 5 and above. So turn it 6 to 1 and add it to this one, become 2. So that's what? 0.9 decimal. What if you are given a big number? You know, we are taking the proper part. What if you are given in proper fraction? For example, we are told to convert 515 over 12 in decimal. What will be it? First, you can convert it to what? Mixed fraction. So 515 over 12 in mixed fraction is what? 42 whole number 11 over 12. So first convert to mixed fraction. Then the proper part we cannot convert to decimal. And according to what we did here, 11 over 12 is what? 0.92. Just write 0.92. So that's the answer. So if you are given improper fraction and you are told to convert to what? The decimal, you can first convert that one to mix. So this is the whole number part. So this part will not convert to decimal. It's easier to convert this one to decimal. Then you can put two decimal places and that will be the answer. I've given several examples on how to convert fractions to decimals. 1, 2, 3, 4, 5, 6. I gave 6 examples. And I talk about approximation a bit. Fraction to decimals. Then we've already done fractions to percentage. So what is now left now is now between percentage and decimal. So next is percentage. Percentage. I will not give you an example. So let's convert everything here to percentage. If we want to convert to percentage, we just multiply by 100%. Suppose I have 0.21. To percentage, I'll just multiply by 100%. And multiply by 100% means we are going to add 2 zeros. Or we are going to shift the decimal point twice. So the point is here. I'll shift it twice. 1, 2. That will be 21. Here, I have decimal point here. I'll shift it twice. 1, 2. For 0.5, if I shift this one, 1, 2, this will be a new point. So there will be 0 here. So what would we have here? 50. So it means 0.5 is actually what? 50%. But in case if you want to convert decimals to percentage, you should ensure that the decimal places is at least 4 decimal places first. So that is why it is more proper if you are given a fraction, if you want to convert to percentage, multiply the fraction straight. Don't convert to decimal first because sometimes you approximate. So, but let's manage. If you want to convert 0.67 to percentage, I have 2 numbers here, so I'll shift away the 2 numbers. So the answer is just what? 7%. What about 0.75? 75%. What about 0.44? That is what? 44%. What about 0.92? That is what? 92%. Let me just give several numbers, several decimals, and let's convert them to percentage. So look at this question. Convert 3 over 4 to decimal, then to percentage. So let's do that. So, what will be inside? The numerator, which is what? 3. Outside 4. 4 in 3, impossible. Put 0 here. 4 in 30, that should be 7. 7 times 4, 28. Subtract, we get 2. Then put 0 again. 4 in 20, 5. 5 times 4, 20. And that's the end. So it means 3 over 4 equals to 0.75. So that's the decimal. Now let's not convert 0.75 to percentage. What are we going to do? You multiply by 100%. We are not changing anything because 100% is as 1. Then here we shift the point twice. 1, 2, that's 75. 75%. So it means 3 over 4 is 0.75 in decimal, and it is what? 75% in percentage. Now, this question, convert 12 over 25 to percentage, then to decimal. So that should be more direct. 12 over 25 to percentage, just multiply by 100%. Then how many 25 can we see in 100? That will be 4. You can cut it. 100 to 25. You can start with 5. 5 in 10, 2, 0. 5 in 5, then 5 in this, 4. So 25 in 100 is 4. So now here 1, 25 here is 4. 4 times 12 is what? 48. So it means 12 over 25 is 48%. Now let's now convert 48% to decimal. That means out of 100, that's 48 out of 100. So what will be the answer? We are going to count backward twice. We have two zeros here, so we'll do 1, 2. That will be 0.48. So it implies that 12 over 25 in fraction is 48 in percentage, and it's 0.48 in decimal. So let's quickly talk about how to divide numbers by multiples of 10. Suppose I have 48 over 10. What will be the answer? 48 over 100. What will be the answer? 48 over 1,000. What will be the answer? 48 over 10,000. What will be the answer? Note this down somewhere. So if I have 10, that's 1 0. I'll move once. So I'll fall in between. That's 4.8. Here I'll move twice. I have two zeros. 1, 2. The point will be beside 4. That will be 0.48. Then I put 0 here. So here I have 3 zeros. So 48. I'll move 3 times from here. 1, 2, 3. The point will be, so there will be 1 0 here. So that will be what? 0.048. Next one, I have 4 zeros. So 4 8, 4 zeros, you go for 1, 2, 3, 4. 0 here. That will be what? 0.0048. Now to divide by 10, by 1,000, by 2,000, and the likes. So let's move to another example. Before moving to the next example, ensure you note this. I want to write it off. Convert 0.125 to fraction, then to percentage. So if I have 0.125 to fraction, we can't. Just negate the decimal point, that's 125. How many zeros do we have here? We have 3 numbers here, so to have 3 zeros. So this is the fraction. So what about the percentage? Although this is not the least fraction. So let's cut to the list. So to the list, this becomes, let's say 25 straight. So 25 in 125 should give us 5. 25 in 100 is 4. Then 5 here, 1. 5 here, 8. So 0.125 in decimal is 1 over 8 in fraction. So let's now convert the fraction to percentage. But instead of using 1 over 8, I'll use 125 over 1,000. Why? Because 1,000 can easily cancel 100. So this 0.125 in fraction. To percentage, I'll just multiply by 100%. What happens here? 2 zeros from this cancels 2 zeros here. So I'll be left with only what? 1 0 here. So that will be 125 over 10. So I have 1 0 here, so I'll count backward once. That is what? 12.5%. So it means 0.125 in decimal is 1 over 8 in fraction in the least form, and 12.5 in percentage. With this, I believe you can now know the connection between fraction, decimal, and percentage. How to interconvert them, because they are all interconvertible. So the next thing is to talk about operations with fractions. So we've learned how to add, subtract, multiply, divide to a certain level when we have. But how do we add fractions? We've done those, but now we want to go deep down in addition of fractions and subtractions, multiplication, and division, where we have the 4 operations together. And that will be centered on vulgar fraction, meaning fraction with numerator and denominator. This video is getting too long, but please permit me to add one more thing to it before we move on to the next lecture. How do we add decimals? We've given some examples, subtractions, but how do we multiply decimals? Let's talk about multiplication of decimal fraction. I want to do this here now because we are still going to use the same approach as how we multiply whole numbers. Look at this. Look at the following examples. First, when you see something like this, neglect the decimal sign. In this case, I'll neglect this point. So we just have 3 times 5. 3 times 5 is 15. Then we have just a single number after decimal point. So at the end, we have a single number after decimal point. So the answer is just 1.5. For 1.5 times 1.3, I will just do 50 times 3 straight. We'll neglect decimal points. 3 times 5, 15, carry 1. 3 times 3, 1 plus this 4. 1 times 5, 5. 1 times 1, 1. Add 195. So what's the answer? 195. I have one number after this decimal point, another one number here. So at the end, we have two numbers. So I'll leave two numbers here. We'll go 1, 2. Leave two numbers here. Next one is 1.25 times 2.1. Same thing, neglect decimal point, multiply normally. 1 times 5 is 5, 1 times 2 is 2, 1 times 1 is 1. 2 times 2 is 10, 2 times 5 is 10, 0 carry 1. 2 times 2, 4 plus 1, 5. 2 times 2, 2 times 1, 2 rather. So here I have 5, 2, 6, 2. 2, 6, 2, 5. We have two numbers here after this point and one number here. Altogether we have three numbers. So we must leave three numbers here. So we put decimal point here. The last one we have 1.11 times 2.22. So same way, neglect decimal points. 2 times 1, 2, 2 times 1, 2, 2 times 1, 2. 2 times 1, 2, 2, 2. This one, 2, 2, 2. So let's add 2, 4, 6, 4, 2. 2, 4, 6, 4, 2. We have two numbers here, making four numbers. So we have to leave four numbers here. 1, 2, 3, 4. So decimal point will be here. So that is it. As you can see, it's very simple. So what is left is, how do you add decimals? It's simple. We've done that before. If I have 2.5 plus, let's say 121.67. So write the bigger number first. We have 121.67. For the next number, write the decimal point first, because decimal point must align. So you put 2 here, you put 5 here, then we add normally. This is 7, this is 11, 1 carry 1, this is 4, this is 2, 1. It's very simple. So next class we'll focus on vulgar fractions.